All right. Part D says to find all the x values in the interval from -5 to 5 at which g has a critical point. So we'll review the definition of a critical point. Classify each critical point as either, I'm going to get all my colors involved, a minimum, a maximum, or neither. Right? If the first derivative doesn't change from positive to negative or negative to positive, then it can't be classified as a max or a min. And then, of course, justify your answer means you better write a justification sentence. Okay, so we are thinking about g prime of x here, which is just the values of f of x. So if f of x has critical points, the definition of a critical point means we want to figure out where that function is 0 or where it does not exist. Okay, we reviewed that a lot back in chapter 5. That a definition of a critical point has two pieces, not just where the derivative is 0, but also where the derivative might not exist. All right, so when I look at the f of x graph, a lot of you thought that these cusps meant that the derivative does not exist, but I'm looking at the values of f here. There is no place from -5 to +5 where the values of f do not exist. So for this particular problem, this definition is out. We only need to worry about where the derivative of g, or that means in this case where the values of f are 0. So that's here and here. And already by determining that, so f of x is equal to 0 at x equals -2 and 1, we've already gotten quite a few points here on the rubric. So now we need to classify these as mins, maxes, or neither. So we'll set up a first derivative test. We go -2 and 1 is 0. All right, so the values of f are our slope values here. So here on this side, the values of f are negative. Okay, because the graph is below the x-axis. And then again here, between -2 and 1, all of the values of f are negative. And then from 1 on to the end, all of the values of f are positive. So the function is decreasing, decreasing, and then increasing. So that shows us on our test that -2 is neither, because the first derivative does not change signs around the critical value point. But I can see at x equals 1, it goes from down to up. So I can classify this as a minimum value. Now I'm ready to write my justification sentence. So at x equals -2, g of x has a critical point, but it is neither a max or min, because g prime of x does not change sign. Okay, so you could just talk about changing from positive to negative. I'm going to write a different sentence for the next one just to give you guys some variety. Whatever you choose on the test day is fine. Just make sure it's a complete justification. At x equals 1, g of x has a min, because here I'm going to use intervals from -2 to 1. G prime of x is less than 0. And from 1 to +5, g prime of x, watch your notation here. Notice how I'm using all the notation given to me in the problem as well, is greater than 0. Okay, so two different types of sentences you could write. One, I used intervals and negative and positive values using inequalities. Here I just talked about if it changed sign or not. If you remember when we looked at student samples together in class, both types of sentences were awarded points on the scoring rubric. Check that out. Email me if you guys have questions.